In this video, I'm going to be breaking down what is system design. System design is probably one of the hardest topics in software engineering, and luckily, Martin Kleppmann wrote an entire book that's one of the best books to break all of it down. But the book is also really hard to read, and so I'm going to be breaking it down from step by step. In this video, we're going to go from what is system design and then slowly move into why does it even matter, how you can actually learn and understand what's actually happening here. If you don't know who I am, I'm Raymond. I have 5 years of experience working at Citibank and Walmart. I've also read 4 different system design books, and I've solved over 1,000 Leetcode problems. Now, let's get into the video. Number one, system design is something that you've already done before, typically through object-oriented programming. This is not something that's super crazy. It's not really scary. It's very straightforward. And Kleppmann does a really good job in the book talking about how why we're doing this way, why are we creating all these big scalable systems and all this stuff, whatever. But at the very start, I just want you to understand that you've already done system design before, and that when you first do system design is when you're doing object-oriented programming. And this is this kind of idea that you can model some real world object into code, and through that code, you can build a just generally more organizational structure. And then when you have that generally organizational structure, you can actually start building out really big code bases with it, which is why this is taught so often in computer science, and also why it's tested of junior engineers. So the first system design thing that you're going to be doing as a junior level engineer is going to be a low level design, is what they call it, which is literally just object oriented programming. They just, whatever the names, tossing out names. But at the end of the day, you're designing some kind of system, something that's going to be taking in data, something that's going to be spitting out the data. And so at a higher level, yes, system design is really complicated, but at its core, it's really just learning these key components. And then it's kind of just expanding on object-oriented programming, really. So Kleppmann starts off the book by saying that data is everywhere. In 2025, data is only going to be even more important to be something that's stored. Essentially, it's really easy to store small files, which is what we do in, college. But it's really hard to install systems, to develop systems that can handle millions of data, millions of users. And so the idea of system design at a high level, when we're doing it in this book, and moving above that, college level, is that okay, now how can we get this to millions of people, not just one user? And this is what he calls a data intensive application, which is that a system, an application that's going to be ingesting loads of data, millions of data, billions of data. I don't know. I don't know if billions is a word, but we just did it. So, and you can contrast this with compute intensive, which is going to be requiring parallel processing, where the limit is, it's not the billions of files. The limit's just that we can't go 0 to 60 in 2 seconds, like a Tesla Plaid. All right. Second thing that we do want to talk about is okay, so what are these common needs that's in a data intensive application? What are these systems that need lots of data, right? And honestly, I would just call these I wouldn't even call this a data intensive application. I would prefer to call this a just real world application. So Netflix, Google, Amazon, right? What do these things need? What does Amazon, Google, Netflix need? Because I don't he's true when he says this, but you don't actually have something in your mind. But think Google, think Netflix, think Amazon, right? Well, you're gonna need to be able to store the data so you can find it again, which is a database. He mentions here, and these are the core components of system design. Just so you know, so you need a database, you need a cache, you probably need stream processing, you probably need batch processing. And what are all of these things? Okay, well, you store data so it can be found again. Cool, that's a database. Oh, so we can remember the results of expensive operations. That's a cache. We can allow searching by an index. That's Elasticsearch, or I think Postgres also allows it. So you can also, it has its own indexing that you can kind of do search queries on. Okay, so we want to be handling events as soon as they occur, right? When imagine in a video game where you need to update player locations. Okay, well, we need stream, right? We want to periodically crunch a large amount of data. Okay, well, this is batch. And so all systems are really going to be having these things. This is the core thing of his book, honestly. And this is what makes it so hard, is that actually building these out, it's actually building these things out at a high level. So that is, that's kind of that part. And so in this book, we're going to be talking about the ways that you can store data. Like this is what Klutman's going over, is that, you know, only big companies really need this, but even startups are starting to deal with like big data. And I've noticed this too, where I'll interview at some startup and they're like, I need to know that you know system design. And I need to test you on that. And so data is getting big and the problems are still here. So it's a good skill to have. It's a good skill to have on your resume. It's a good skill to have, you know, for longevity, because data is only going to really be growing. And it's also a good skill to have for interviews. So overall, like the first chapter of his book is just going over, okay, what's the difference between operational and analytical systems, right? So like, what are these like there's two types of data actually or two types of like kind of styles of data. There are, and then after that is going to be, okay, well, what's about cloud? What is cloud computing? Like, why are we using cloud? Why is everyone talking about AWS and Google Cloud and Azure? And then the second thing is like, okay, well, what if we just host it ourselves, right? What are the pros and cons of doing like stuff like that? And then when do we go from like one node, which is he calls a node, I would call this a server, to when do we go to like hundreds of servers? And then it also talks about balancing the business needs and then rights of the user. So things like privacy, how do you have the privacy of data, and how can we make sure that that's good? So that's what this is the roadmap. This is what we're going to be talking about at each level of this. And this is going to elevate your understanding of system design. And it's going to be overall like, yeah, just a cool thing. Actually, before we even talk about like analytical versus operational, I want to give you like a real example of system design. And so let's look at this. Let's take something like Twitter, where we have a user and then the user is going to post, right? So this is an example system where like, okay, user wants to post. And so they click some button on their phone that says like they want to post. And so like we essentially, this is system design. What I'm showing you is that like, okay, so what's going to happen when they post? Well, we're going to have a server that's going to be waiting for them to post, and then we're going to write it into a database so they can see the post later, right? So then we're going to draw the database, or not first the server that's going to be accepting the request, right? So then it would be like post service that's going to be accepting the request. And then we're going to have something here, which is like the database that we're going to have. And this is like 99% of system design, just to be super clear. Like it will always start here with just these three components: some database, some server, and then some user interactions. And so when we go into this next chapter, what's going to be happening is we're going to be going over like what are the different types of like things, right? So like this is in most cases, this is maybe 50% of system design, like systems, is that like someone wants to post something, we go in and we post it. Okay, but like then there's this other part where like, what if somebody wants to run analytical queries on it? And so this is what Klutman is talking about when he says like, okay, well, you're going to see some backend engineer who's going to be handling requests and updating data. So what if someone wants to edit their post? What if somebody wants to make a new post, delete the post, whatever, right? And then we also have analytics, which is going to be that like, and this is something that you would be tested on if this was an interview, but it's also something that like we have like two systems. Like this is like, I would say 50-50, is that analytics are just as important. And so now we have a analyst, not a user, who says how many users, I don't know, have like, say like curse, like swear, I don't know. Maybe we want to do like a swearing analysis. And so he's going to be dipping into the database, but he's doing something different. He's not making a post. He's searching all posts that's inside of this database. And so these are very, very different things, because now you have to read the entire database, and it's very expensive to read an entire database every single time. And so what we do instead of doing that is that we give them their own database, right? And so they have like an analytical database that's going to be used for these queries. This is very important because this would actually crash your system. If you have a person here who's wondering, trying to run analysis, how many users are swearing, how many users are doing this, what are they doing this, where do they live, it's exhausting, right? I'm exhausted talking about it. And how do you think the database feels? It feels exhausted. And so what we do is we nudge it over, have an analytical database. That's the answer to that. But this is kind of like the idea that Klutman is talking about here, which I like the way that I describe it. The way he describes it makes sense. It's totally logical. And I really like it. Again, love this book. Super great book. But this is how I would describe these kind of like two different things. Is that you're going to have data scientists, data engineers, analytics, tons of stuff, and they're just reading data. So now he's going to talk about, okay, well, why are we reading the data? Like, why are we keeping these things separate? And the more you understand this stuff, why these things need to be separate, is like you are building the system design knowledge. I just want to make that like super clear. Like this is very important. And so for interviews, you're going to be asked to build out analytic systems. You're going to be asked to build these things out. So it's very important that you know them because you're going to be tested on why are we doing it this way? Why aren't we doing it this way? And the question is, the answer to that is like it would nuke the system, right? And then for real life, like this helps you understand that like, okay, it's not a one size fits all for system design. You actually need to consider the context, consider what's happening so that you can make the best decision. So let's talk about characteristics of them is what he talked about. So he calls it a transaction processing, and there's processing and there's analytics. So in the beginning, kind of fun fact that he mentioned in the book is that databases were only used for commercial transactions. So placing orders, making sales, paying employees their salaries. But like now, transactions aren't just used for money. It's used for posts, movies, or moves in a game. I'm sure for movies too, but it's much more broad. Okay. And what we're going to see here is that we have the basic pattern is just generally the same. So we're going to have like some kind of records, and then we just want to look at them, that we can insert and delete them. So this is called an OLTP. If you want to be like super fancy and academic, you can call it an OLTP, online transaction processing, which is very different from an OLAP, which is what I described earlier, which is going to be aggregating data. What was our revenue of our store in May? Very different from add a record in May. Let's do the pros and cons. Analytic databases give users full access to the queries. OLTP splits it off so that users do not get read access to everything, and then on the other users. There's other pros and cons too. He actually has an image in his book. I would recommend, I'm not sponsored, not affiliated, but you can read his book for free for 10 days if you go on O'Reilly and make an account. So would recommend that. And next year, we're going to have the data warehouse. And so companies that I told you earlier, which is that like, what I told you earlier was that companies separated the OLTP and then the OLAP systems. And another thing here is that they also built out database warehouses, which are like, because we have like tons of like processing that can be happening. So, oh, what's this website? What's the checkout? What are the registers? What's the inventory? What's the HR employee info? What's the routes for the vehicles? All of this stuff. We just separate the databases, and then we kind of can put them all into different regions, can put them all into like a little box, like all in a house together. And so that separation is going to be useful. And it seems that some database systems are now offering like some hybrid. So we're kind of moving towards not separating them, and like we're kind of having them in the same one. And these are great for scenarios where you only occasionally need to update the rows, but you still want like the full table scans. Apparently, I didn't even know about this, but cool, fun fact. After this, we have a data warehouse to data lake, and warehouses usually are relational, need to be queried, but business analysts like don't know a whole lot about like that kind of stuff, and so it's pretty complicated. And so they prefer using Python. They prefer using like, NLPs, MLs. And so there needs to be like a difference. There needs to be like some kind of change. And so a data lake is this idea that like you have a central repository for any copies of the data. And then when they need the data, like you just send it out to them. So you keep the raw copies and then send it out to them without any actual like data model, or you just give them like directly the file and they can run their own Python like scripts, queries, whatever, right? So this is part of like some sushi principle. I haven't really heard about this, but just like raw data is better, right? So we just give them straight the raw data. I don't know a whole lot about ETL processes, but this is a part of like the pipeline. So you have like a raw data central repository, and then you kind of ship it out depending on what they want. So analytics are, Kleppman mentions in his book that analytics are improving like a lot, and a lot of people are investing more attention into analytic systems and data pipelines. There's also like a data ops manifesto that's written. He attaches that at the end of his book that you can go to read. You probably Google it too. And then these can also do streaming with data events now in like real time, which is cool. So that's kind of it for like the analytics side and transactional side. I kind of big thing I would take away from like this chapter or this part of the chapter, we're still in chapter 1, is that I hope you're seeing like how complicated system design is, because now we've got like all these data lakes, data warehouse. We've got like all these servers that are put together. Sometimes they're like hybrid put together, but it quickly starts to add up. Um, I think probably for, if you could just understand one of those sections, I think you're good. Honestly, like it depends on which level you're at. If you're going for staff, then obviously you need to know a lot. The expectation is that you know both of these systems, but I think knowing just one is fine, honestly. So like for most people, maybe maybe for senior, if you're trying to go senior at Google, that's maybe a bit of a different case. By the way, if this stuff is really, really complicated and you're not understanding it, I also could talk to people one-on-one on a call where I can just walk you through all of this stuff completely for free. You can join it in my school group, or you can, I think I might have a Google form link that you can use to submit. You just have to have 2 years of experience as a software engineer, and I'll hop on a call completely for free and break this stuff down to you. So now we're gonna be talking about systems of record and derived data. Again, I prefer to like give examples of how this stuff is used. And so this idea of like a system of record is that like when we want like some kind of data, like we can have a source of truth. So we can just make sure we have data that we know is 100% right. Let's call this like the source of truth. And then we can just start modifying that. So very similar to that repository idea, right? Which is raw data is better, but we're just going to be like sending it out to people. Very, very similar ideas. And so this is the cool thing about this is the cool thing about system design, is that there's a lot of like related kind of concepts, but this idea of system of record and derived data applies to the data lake, and it also like transfers over into like some other areas. So it's useful to know these like rules that are being out, because that come up because they like pivot over into other ones. So system of truth is that we're gonna have like some raw data. Everything's written. Each fact is normalized. Like each fact is only once. There's no mismatches. System of record is the right one. It's the correct data. And then we take derived systems, just take data and then they change it up into a different form. So this makes it great for reading data instead of recalculating every time. So again, let's imagine we go into our post system. Well, we have our post database. This is our truth, our record. There's only one post. Like we make sure like everything is like tight and good. And then what we do is we can convert that into some kind of like analytical type of data. So maybe we could sort the posts by year, date, whatever. We can just pop them into something else. Or we can modify the post. We can add in like emojis or whatever. I don't know. But next thing that Kleppmann goes over into the book is cloud hosting versus self-hosting. In this new age, this is actually a new part of his book. So he does not talk about this if you go to his version 1 of his book. If you buy the one that's on Amazon right now, he doesn't talk about this. He also doesn't talk about like the chapter doesn't start off as like nice. He kind of really just gets into it about systems, I feel like. And so you're getting eased in a little bit on this one. And also he gets to talk about cloud and also privacy policies, which are, growing issues in our systems. That said, that the cloud hosting is also really important, because like this is what most companies are doing, right? So most companies, if you go on their websites, they will say we're using cloud, we're using AWS, we're using Google. They're also using like AI. Sad that he doesn't have AI in his book, but what can you do? But they're all using it. And so it's really important that you understand, because if you're going to be a software engineer in this day and age, you need to understand why are people doing like this thing, right? How would you decide for your company what to use? And so I don't think this comes up often in system design interviews, this idea of like self-hosting. I think it sometimes does. Just kind of like a fun fact. Most are just happy to see you do cloud and they don't care at all. Like they'll just say like, yeah, man, it's all good. Again, maybe different if you're doing staff. I don't know. I wouldn't know. I'm not at that level yet. So the question is, okay, well, should you use cloud? Should you go in-house? The management wisdom is going to say, okay, well, you should only do in-house if it's a core service. And then if it's non-core, well, then you should be left to a vendor. And I don't know anything about this. I guess so. I don't know. But most companies don't use their own electricity. Like they just use the grid. So, you don't have to do everything from scratch. And so Kleppmann kind of argues that it's a spectrum of like control that you want. So in-house is more investment upfront and more control. And then cloud is less investment upfront, but you get less control. And Kleppman also argues that like if you have the skill, setting up your own is just cheaper in the long run. Like the most expensive thing is that you have to buy a software engineer. You have to pay them a lot of money, $300,000, whatever, to set up the system. And you're paying for like kind of like that skill, like that labor. And that is expensive. But if you already know, if you already have a team that's already has like the skills, if you already know like this stuff, well then you can just set up your own yourself, and it's probably going to be cheaper than paying a cloud provider. Mentions that cloud requires way less skills. So again, you don't need to train staff to use your cloud. Not really. It's pretty easy to learn than building up your own server data warehouse. Cloud's going to be more flexible. The load varies a lot. You can literally just not spend any money if it's zero. So that's great. Cloud's downside is like its lack of control, right? So the service can go down, means that you can literally only wait for them. You can't fix it yourself. You just got to say, hey man, AWS is down. What can you do? AWS rarely goes down though. I mean, it does crash a lot, but not too much. It's like pretty good SLAs, I think, service level agreements. If it lacks features, you can hopefully ask the vendor to include it later, right? So you don't get the control. And then cloud provider is trusted with data privacy and security. Other things here too, right? So we've got different types of like options. So we can do MySQL, we can use AWS Aurora, we can use Azure SQL DB, we could use Spark, we could use Snowflake, we could use BigQuery for the analytics. These are things that probably would impress an interviewer, and also like just helps your knowledge out too. I know Jordan House in Life is doing like essentially a series where he's just going through every single technology, just going deep into them. So that's pretty cool. But you get a lot of options here. Different level clouds. So there's like actual VMs, and there's like S3 bucket files. And then you've got like differences in like storage and then compute. So EBS, Amazon EBS offers virtual disk storage. So it's like blocks of data. And then if you want long-term storage, you can push things out for S3. And so essentially like these old sysadmin admin, like I'm running the server, and then these cloud people like jobs, like they're kind of like blending together, like these DevOps with cloud stuff is like blending together. It used to be in the case, I'm guessing based off Kleppman, is that you had like some guy sitting in an IT office just ordering up the databases, making sure the system runs right. But now you've got like these cloud people who are configuring all of these things and choosing like which was like the best one. It's a real job. It's a real job. And so that's all I've, kind of got out of Kleppman for the cloud versus no cloud. And you can kind of just make your decision based off that, kind of go by ear, or research more into the cloud technologies, understand them, how they work, what are they actually doing, and how hard is it to actually build your own, SQL database or data warehouse. Okay, so let's talk about the problems with distributed systems, because this is going to be this is like probably one of the biggest parts. There's literally a chapter in the version 1 of the book that's whole dedicated to all the problems that can arise with distributed systems. And so kind of like the idea here is that when you're doing system design, okay, so we have this, right? So we've got like this user wants to post something, they post, we put it into the database. Now the question here is that like, what if we have 1 million users who all want to do it? Well, this all can't fit on one server. You cannot have one database. And so what you actually do is you put in several different databases. So you put one here, one here, one here, one here. And now you've got to like route all of them. And so there's a problem that happens when you need to draw out like 5 different arrows to connect to 5 different databases based off like some user ID and location. So this is, kind of what we're talking about, which is that like, okay, well, what's going to happen when we distributed systems is just like we're plopping even more databases, even more servers, and they all need to kind of communicate to each other. So the distributed system can fail way more often. Every network request can fail. The internet can always go out. It's also way slower to do network calls than calling a function in a system, because you have to transfer it over the internet, and internet is way slower, which is why we're using cables. It's why, you plug your monitor through with the cable, because it's just too slow doing it through the air. Troubleshooting is also really, really difficult for distributed systems. Things will go wrong all the time in distributed systems, and it is unavoidable. It cannot like be fixed. And also it's really hard because you don't know if it was like a server error, you don't know if it was a hardware error, you don't know if it was just like, who knows, right? So overall, using a single machine is just way simpler, way easier. And again, there's going to be another chapter, or at least where I'm going to be talking about this at a much longer depth than just like these 3 minutes. But I just want you to understand is that like distributed systems are hard because so many things can fail because of the internet. And And it, you know, in the best case, it's just easier to use a simple machine because it's simple. It'll be cheaper. It's simpler. Need less skills. Going into the book, last two parts, we've got microservices and then serverless, and then we also have like privacy. And talking about the microservices for a little bit, one is that like in the past we had like the service-oriented architecture that was used, but like so you would have like one monolith. And so what is a monolith? It was just like like you would have a one computer that would just run all of like one code base, one computer, whatever. You'd have one thing that's like houses all of it. So like the post would be here. And then also inside, like you would have some routing logic that would do for like user profile updates. And then you would also have like, again, we're talking about Twitter here. What other things can Twitter, you know, tweets do? You'd have like a follow thing, but you would just mash them all together in the code base. But now we're doing like different repositories that are deployed on different servers, as opposed to just one server that's running everything inside. And instead of doing it like this, right? So instead of having like, they each have like their own kind of thing, right? So we would have a user profile service, and then we would have a follow service. And so when anytime somebody needs a follow, instead of posting like when they want to follow, then we route them over to the follow, and then route them over to the profile when they want to change their profile. And so this helps distribute the load, because maybe there's a ton of follows, but there aren't that many posts. And so we just want to like be able to make sure this one's scaled out as opposed to scaling the whole thing out. And also for teams, working together in teams, you just expose the API for the access and teams can work together a lot. So it makes it easier to scale. Coordination's easier. You can make changes, updates that are free of charge. The only downside to this though is that things are harder to evolve. So like when you make one change to something here, well, now you have to have everything structured, because if something is dependent on another thing, well, now you've got to like change this other one. And you know, there's actually a really, really, really funny video actually on this. So there's actually like a really funny video on this about all these dependencies. And I would totally recommend you watch this video. This is some good stuff, because it is 100%. This is 100% true, which is that like when you want to change something, well, now the entire dependencies are like moving. And so he's like drawing out this thing, like he's like, yeah, man, like there's like Galactica. So it's like, oh, so how long is it going to take us to change this feature? It's like, okay, well, you don't even know what you stepped into, because we got to make this change. We got to change this microservice, but this microservice is actually dependent on this microservice. And this one's actually dependent on Galactus. And then you got Badger, and we got EKS, and then we've got, this other ones. And like by the end of it, he's just like crying basically, right? Each, you know, service is going to need the infrastructure. You're going to need to deploy the release. Kubernetes is going to help with it. Testing during deployment can be complicated because of all the dependent services that you also need to run and test. And it's like really just a technical solution to a people problem. So like you can't have 1,000 developers working on one project, because with the way that Git works and the way that like merging and doing code reviews and doing all that stuff, it just gets like a mess if they're all messaging in like one single repo. And although this may just be my take, I don't know if Klutman actually says this, but this seems to be like my understanding. I think he said it was a technical solution to a people problem though. And then serverless is that like instead of doing a microservice, you just queue the job onto like cloud, and then the cloud will just like run it independently. And then you got supercomputers, right? So if you need to run complex solutions, we have like these supercomputers that we use to run really crazy algorithms. And then on GDPR, I didn't even bother really looking at this into too much detail. I think it's just how are you going to be disposing your data? But yeah, so this is that was the first chapter of designing data intensive applications. If you liked it, if you enjoyed it, make sure to let me know in the comments if you want me to do something like this again, where I just go through just drilling through system design. If I made some mistakes in the video, let me know, and I will try to like fix them. I'm going to be looking at the videos too, seeing like what I did wrong and whatever. And overall, like this is probably one of the best books for learning system design. If you want to get good at system design, like again, I can't recommend more than enough for reading this book and understanding, really understanding these concepts. And if you do want more, well, I made a 1-hour video going over version 1 of his book. It's like almost 1 hour long. I'm just rambling, going off, explaining and breaking down every single concept there. And I also have another one by Alex Shu, where just way more practical for 2 hours going through all these system design type of projects. So if you want to like check out either of those, you can do that. I would recommend it, and I will see you in another video.